Hello guys, welcome back. So today we have another question from GATE 2021 based on network theory, and here is some question related to mutual inductance. So the input impedance Zn of S for the network shown is dash, and they are given 4 options, and this is our network. And if you observe, this inductance is 6 Henry, this is 4 Henry, and they have a mutual inductance of 1 Henry, and these dots say you that they are coupled positively. So what it means, let's say I have a inductor, okay, and its self inductance is L. So now if I pump a current I1 through it, let me call it L1, what will be my voltage V1? So my V1 will be L1 dI1 by dt. So how is this happening? This is happening because of the magnetic flux produced by this inductor L1. Now if I have another inductor L2 close by to this inductor, then what can I say? The magnetic flux produced by L1 is also going to affect L2, right? So that amount of flux affecting L2 is given by my mutual inductance M. So now if they have dots in the same side, it means that they are positively coupled. What it means is, if there is I1 flowing into this dot, there will be a positive voltage generated at this dot. So if my V2 is this way, my V2 will be L2D, let me take this as I2 by dt plus M into dI1 by dt. So now if it is on the opposite sides, so if it is like this, and this is I1, I2, L1, L2, then my V2 will be L2 di2 will not change because it is only dependent on L2. But here I will have M di1 by dt. What it means, now whatever current is flowing here is I1, but my positive side is on the negative of V2. So it will be minus. So here for the second case V2M alone, you can think it as it is getting generated like this. Okay. So now let us go back to this and try to find in the look-in impedance. So here again we need to assume our current I1 and I2, and if you see they are asking it in the Laplace domain, you have S here, so we will go to Laplace domain. So in Laplace domain, how will this equation turn out to be? My V2 of S will be SL2 I1 plus SM, sorry this I2, right, SI2 and I1. Here if it is this case, it will be V2 of S is equal to SL2 I2 minus SM I1, and this I1 and I2 are also Laplace domain. Okay, so here let us see what happens. So let me call this voltage as V2 and this voltage as V1, and to find Zn of S, what I'll do is I'll connect a current of 1 unit 1, so this 1 ampere in Laplace domain. Okay, so then I need to find this voltage V. So then my Zn of S will be V of S by 1, which is V of S itself. Okay, so now let us try to find. So if this is my V2, what will be my I2? My I2 will be V2 by 5, but in opposite direction, so it is minus V2 by 5, right? Okay, and can we try to write the equation relating V1, I1, I2 and M? So V1 of S is equal to, first it will depend on, let's say, the self inductance. So it is SL1 I1 of S, and it is positively coupled, so it will be plus I2, so plus SM I2, right? So what is SL1? It is 6S, I1 is 1 plus SM, M is also 1, so S into I2, I2 is minus V2 by 5, so minus S into V2 of S by 5. So now we need to find V2 and substitute it here. So can we try to write the equation for this case? So V2 of S is equal to SL2 I2 of S plus SM I1 of S, right? And what is my L2S? It is 4. So 4S, and I2 of S is minus V2 by 5. So minus V2 of S by 5 plus S into 1 into 1. Okay, so it is S only. So this I can take to the other side. V2 of S into 1 plus 4S by 5 is equal to S. So V2 of S is equal to 5S by 5 plus 4S. So now I need to substitute this one here. So my V1 of S is nothing but 6S minus 5S square. No, 5 cancels, right? So S square by 5 plus 4S. So this is my V1 of S. What is my V? It is I1 into 4 plus V1. So my V is 4 I1 of S plus V1 of S. I1 of S is just 1, right? So my V of S is 4 plus 6S minus S square by 5 plus 4S. So if you go back to the options, so these are not my options, so I need to check between this and this. You see the denominator is same, so anyway I have to simplify this to arrive at the answer. So I'll get 20 plus 16S plus 30s plus 24s square minus s square by 4s plus 5. So this is nothing but 23s square plus 46s plus 20 by 4s plus 5. So this is my answer. So if you see here, both has everything same except for the s square term. So what did we get? We got 23. So 23 is the correct answer.